today we're going to look at trigonometric functions. Trigonometric functions is how you say that. But we're going to start at the beginning. We're going to start with your probably favorite theorem from geometry class, Pythagorean theorem and the distance formula. So Pythagorean theorem applies to a right triangle, so specifically a right triangle, where the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse, aka you have a squared plus b squared equal to c squared. Now that's going to be very important for us today as we start solving for different parts of these triangles so that we can talk about all 6 trigonometric functions in regards to angle theta. But I'm going to have you rewrite this formula in 2 separate ways that are probably more useful than just regular Pythagorean theorem. And that would be if we straight up solve this for the hypotenuse c, which means we'd need to take the square root of both sides. A squared plus b squared, we're taking the square root. That actually would solve for c. And since we're usually going to want the actual leg length or hypotenuse length, we don't want it to be c squared or a squared or b squared. We want to solve for the actual letter. But let's say we were looking for the value of one of the legs. We'll let it be leg b. How would you rewrite that formula, a squared plus b squared equal to c squared, so that it was solved for b? C squared minus a squared, and then what on all around it? Square root. Because if it's just regular b, we would have had to square root that to get b by itself. Now, in this concept, we're talking about distances. So if you remember from my algebra class, anytime we took a square root, what did we have to put in front of it? In front of a square root? Plus or minus. Now, can distance ever be negative? No, so we don't need the plus or minus here. It's just always going to be the positive because it's a distance around the triangle. It won't be negative. Cool. Second formula, throwing it back to geometry class, is the distance formula here. The distance between 2 points on a coordinate plane is the difference between the x's squared plus the difference between the y values squared and all of that square rooted. This is our second formula for today. It's our distance formula. That's something from geometry class. Now, this distance formula, if we apply it to a right triangle on a coordinate grid, actually gives us a bunch of the definitions for the trig functions that we need. So to define the 6 trigonometric functions, we will start with an angle theta in standard position. Standard position is a positive x-axis all the way to the terminal angle. So we have this obtuse angle theta. The point P must not be the vertex of the angle, yada yada. See the figure on the right. A perpendicular from point P to the x-axis at point Q determines this right triangle. Do you see the right triangle here? Yeah. Since this point P is where we are meeting those 2 distances, the horizontal and the vertical displacement, we know also that the x value is like one side of my triangle, and we know the height, the y value of that point P, is like another side of this triangle. So if you look at this one, we would have previously called this the hypotenuse, but in this picture, what do we have it labeled as? R. What do you think R is standing for? Bless you. I like that R word. What about a different R word in math? Radius. It is the radius length if there was a circle inscribed all the way around this vertex connecting at point P. So what's cool, though, is if we look at the distance between these 2 points, O, the origin, and P, and use the distance formula, this is the coordinate point 0, 0. So I have the coordinate point 0, 0. This is the coordinate point x, comma, y. So I have the coordinate point x and y. X minus 0 is just x, and y minus 0 is just y. Do you notice that this right here is the Pythagorean theorem that we had just a second ago, but my letters have switched from A, B, and C to a vertical distance, a horizontal distance, and a radius. Those letters, instead of A, B, and C, are going to be how we define our trig functions in this class. So here are the 6 trigonometric functions that you need to know. I will tell you right now, one of my biggest pet peeves is calling these sin, cos, and tan. Ugh. You owe me a quick buck if I hear you calling them that. It is sine, cosine, and tangent. So we have the definition of the sine of theta. Theta is the angle. Sine of theta is the y distance divided by the radius. The cosine of theta is the horizontal displacement divided by the radius. And the tangent of theta is the vertical displacement divided by the horizontal displacement. But remember, the denominator of anything cannot be 0, so your x distance cannot be 0. Those are the three normal trig functions, the typical trig functions. They have what are also called reciprocal functions. And we'll write down how to say these because I'm sure we don't actually know. CSC is called cosecant. You are calling it cosecant. Don't call it because that's weird, but it is cosecant. Cosecant of theta is just the reciprocal of sine, which means that this one, instead of being y over r, is defined to be r over y, the ratio of the radius to the vertical displacement. This second function right here is called secant. Secant of theta is the reciprocal of cosine, which means that it is r divided by x, where x is not 0, obviously. Do y'all know this last one? What is this one's name? Cotangent. Very good. Not cot. Oof, that bothers me so much. Owe me a quick buck every time I hear that. It is called cotangent. It is defined to be the reciprocal of tangent, so it is x over y. So to write the values of all 6 trig functions, all we need to know is the numbers for x, y, and r. And being that x, y, and r make a cute little triangle, we're going to be able to use the ideas of Pythagorean theorem to make sure we know x, y, and r for all values, and we can write all 6 trig functions down. Okay, those 6 values are going to be something we're referring to over and over again, so I'm going to ask you to start to memorize them, and indeed, you're going to have to memorize them by next class anyways, for your next formula quiz.
This?
Yep.
I
Yep.
can't do all this vocabulary.
You're going to have to. So much vocabulary, so little time. So let's see what this looks like in general. A kind of question I can ask you here, and it's going to use those 6 definitions from the front, so you might want to flip back and forth until you have them memorized. Or yes, if you took pre-cal last year or AP pre-cal, you did use these. They're the same formulas. The terminal side of angle theta in standard position passes through the point 8, 15. Find the values of the 6 trigonometric functions of angle theta. To do this, all we need to know is the values of x, the value of y, and the value of r. Since we're given a coordinate point P on the terminal ray, we already know the x and the y. What is the x value?
8.
What is the y value? So I can use the idea of Pythagorean theorem and that relationship between x, y, and r to find the missing radius. That means I'm going to do the square root of 8 squared plus 15 squared. Fill in my numbers in the correct colors. And we'll be able to find out what the radius is. When I'm typing this in personally in my calculator, I don't put the square root at first because there's a lot of times it doesn't come out to a perfect square and we have to do something else. So I would honestly do 18 squared plus 15 squared, press enter, and then square root that number to see if it's pretty. If not, you already know the number that would be underneath the square root. But I digress. R is going to be equal to 17 here, which means we can fill out all 6 trig functions for this angle theta. We would say that the sine of theta is equal to the y divided by the r, 15 over 17. We would say that the cosine of theta is equal to the x divided by the r, 8 over 17. And we would say that tangent of theta is the ratio 15 over 18. Do we see how I got all of those? I like to write my answers in this stack like this because right next to it I can write the reciprocal values and I just have to flip the number over. The reciprocal of sine, remember, is cosecant, and all I have to do is flip that number over, 17 over 15. The reciprocal of cosine is secant, so all I have to do is flip that number over, 17 over 8. The reciprocal of tangent is cotangent, and so boom, just flip that number over, 8 over 15, and I've done all 6. Once you get 3, sine, cosine, and tangent, you use the reciprocal value for cosecant, secant, and cotangent. Acceptable?
No.
Too bad. Let's try another one. It's not at all any more difficult. Because I've given you the same information. It says the terminal side of angle theta in standard position passes through the point -3, -4. Random question, what quadrant am I in if my coordinate point is -3, -4? Bottom left, which is quadrant 3. Very good. Find the values of the trig functions of angle theta. Okay. If we just list out what we know, what is the x value? -3. What is the y value? -4. And so I can use that information to find r. This is when your parentheses are going to be very important. Make sure you actually use parentheses when you're finding these values of r in Pythagorean theorem, no matter which direction you're using. So -3 in parentheses squared plus -4 in parentheses squared, and then square root it. What do you get? 5. Leading up to our 2-minute warning for lunch, since that bell just rang, let's see if you can list out all 6 trig functions. I'll write them down during lunch, so when we come back, we'll start immediately with example 3. But go ahead and try to write the 6 trig functions that we're missing in this example 2. How did we do on this one?
Perfect. About the same as quiz.
Okay, so you need a 10-point bonus.
Yeah.
Okay. So the third one, it's the same question, but I'm giving you separate pieces of information. This time, it says to find the 6 trig functions of the angle theta in standard position if the terminal side of theta is defined by x plus 2y equal to 0, and x is greater than or equal to 0. Be sure to rationalize any denominators if needed. So here's what I want us to do this time. The information we were given is a relationship between x and y. So if we take this relationship, x plus 2y equal to 0, and we solve it for y, we'd subtract x from both sides, and then we divide both sides by 2, where I end up with y equal to -1/2 x. That is the straight line with a slope of down 1 over 2 times x.
Okay.
When we do slopes, I just said it exactly how I want you to think about it. The slope was down 1, right 2. If I translate that to x's and y's, going down 1 and right 2, what is the x value I should use? The x value, is that an up and down direction? Rise over run.
So I mean, 2 is on the x.
2 is on the x, and -1 is on the y. That's our rise and our run, our y's and our x's. Yes?
Since it's negative, either way, 1 plus 1 be negative? Or does it have to be 1? Does it matter which one is negative?
Technically, no. However, I also know that x has to be greater than or equal to 0. So in this particular problem, can I make the x the -1? No. So we're making sure we're paying attention to both things. Okay, it'll tell you some sort of restriction on x, whether x is the negative or the positive one. Which means we can then use the skills we used just a second ago to find r. We know that this is going to be 2 squared plus 1 squared square rooted. I mean, -1. You get what I mean. So 2 squared plus -1 squared. We boop, boop, bop, get that in our calculator. We would get that this is what? Oh, yeah. Sorry. That was my sounds for you to beep, boop, bop in your calculator. Oh, no. If you typed it in with the square root, did you get a nice, pretty number?
No.
No. So get rid of the square root. What do you get without the square root?
Square root of 5.
5. So that is the irrational number square root of 5. We're not going to use the decimal version of it. We're going to leave it there as a square root. Now, note to yourself, if that happened to be like square root of 20, you would have to break the number 20 down. I actually have it on my board. Well, that one says 40 from my regular pre-cal class yesterday. Breaking down the number 40 into simplified radical form. You would have to do that. Do you remember that process with the trees? Okay. But now that we know x, y, and r, we can write all 6 trig functions. So the sine of theta would be -1 divided by the square root of 5. Ooh, record scratch. We can't write our answers like this.
No, it's weird.
You are not allowed to have square roots in the denominator. So we have to do what's called rationalizing a denominator, which is what's in this exclamation point box down at the bottom of your notes. Radicals should not be left in the denominator. The fraction 1 over square root of a can be rationalized by multiplying square root of a over square root of a, which is like 1, so we're multiplying by a scalar of 1, and then reducing the fraction. Easiest way to think about this, because there's the mathematics of why this works. What you're going to do is you're going to move the square root to the top and take the number out of the square root on the bottom. Boom. So negative square root 5 over 5, because negative 1 times square root 5 is negative square root 5. Let's do the same thing then for cosine. The cosine of this angle theta should be equal to 2 over square root of 5, but record scratch, we can't leave square root of 5 in the denominator. How would I write this number?
Square root of 10.
2 radical 5 over 5.
Okay, both of those are great options. Square root of 10 or 2 square root of 5. The correct way to write this is 2 square root of 5. We're just moving it up. We're not multiplying it to that number. Well, we are, but it stays underneath the square root. The 2 is not underneath the square root. You can't just shove it in there.
No.
Okay, tangent of theta. Tangent of theta, remember, is always y divided by x. Do I need to do any sort of simplification there? No, we're good. Negative 1/2. Cool, cool, cool. Let's go do the reciprocals. And this is why I like to show my work here, so that I can see the number when I straight up plug in the x's and y's and when you flip them over. Because if you just go to do cosecant right here and you look back at this value, all you have to do is flip that number over, which becomes square root of 5 over negative 1. Well, that's just negative square root 5.
So the crap with the extra stuff that isn't sine, cosine, tangent, it's just going to be the original form.
You're talking about these three that I would eventually write?
Yes.
They are going to be the reciprocal of the original before I simplify my fraction. So I know that we'll get ahead of our brain automatically seeing that we're going to have rationals in the denominator, or irrationals, sorry, and you're going to want to move it. That's fine. I like to see both before and after I rationalize the denominator, especially when I'm writing all 6, because then I know exactly what to flip over, and I'm flipping over the first one, not the rationalized denominator. Otherwise, I'm making my life harder. You can still do it, it's just more difficult. This one becomes negative, or 2 over negative 1, which is just negative 2. There's all 6 trig functions. Woo!
So we're done for the next?
No, no. No, no, no. That is the main gist of the day.
Oh.
How do we feel about those 6 trig functions?
No.
Good. We're going to just have to memorize the definitions of them, or at least the 3, and know which reciprocal goes to which so that you know all 6. On the next page, we're going to look at the quadrantial angles. Quadrantial angles are like the angles that make up your coordinate grid. So they're like your 0, your 90, your 180, your 270, your 360. Those are quadrantial angles. So it's lying on the x-axis or on the y-axis. Those are your quadrantial angles.
Wait, there's one. You said X.
Yeah. This is a quadrantial angle from 0 to, we're working in radians in this class, or degrees? Degrees. 90 degrees, then 180 degrees, then 270 degrees, and 360 degrees. Those are your quadrantial angles. They kind of like bookend your quadrants, which is why they're called quadrantial angles. Okay? When determining the trigonometric function values of any quadrantial angle, this figure can help find these ratios. Because any point on the terminal side can be used, it is convenient to choose the point 1 unit from the origin, aka radius equal to 1. So if I'm at the point 1, 0, what is the x value? What is the y value? What is the r value? 1. Because if this was making a circle, it'd all be radius 1. So this first quadrantial angle at 0 has an x value of 1, a y value of 0, and an r value of 1. You can see this all the way around for the other angles. Yes, so we'd have 90, 180, 270, 360. Cool. Now, the reason we want to bring these to attention is because when we start to do the 6 trig functions for the quadrantial angles, we sometimes get weird responses. For example, let's do the tangent of 0 degrees. Tangent of 0 degrees means I'm looking at this. I'm going to highlight it. This coordinate point right here. Tangent is defined to be y over x, which means for this one, it would be 0 over 1. What is 0 over 1? 0. Amazing. What if I did tangent of 90 degrees? Now I'm working with this one up here on the y-axis. For this one, what's the y value? What's the x value? What is 1 divided by 0? It is undefined. That's the one we need to be careful of. If you are dividing by 0, you're not allowed to do that. So the value of tangent of 90 degrees is undefined. And that's going to happen for a good number of the trig functions on these quadrantial angles because zeros are involved. Yes?
Can we put that into the calculator?
Thank you for asking. We totally can. In your calculator, first of all, we need to make sure we're in the correct mode. Do y'all know how to change the mode on your calculators? Press mode, and then it always restarts in radian mode, which is what is used most of the time in math.
Yeah.
But in this class for right now, we're working in degrees. If you make sure your calculator is in degree mode by going mode, highlighting degree, pressing enter, then you can, yes, press sine, cosine, and tangent by, and then 90 because we're working in degrees. Now your 90 is going to tell you error. What is the name of the error that it shows you? It should give you an error message. What does it say when you do tangent of 90 degrees?
Value is not entered value entered is not allowed in the function.
Error domain. When you have a domain error, that means that it's undefined. Okay, so this next question, we're going to do something similar to what we did on the front and find all the 6 trig functions for each angle. We're going to start with that angle of 90 degrees. If you look up at the image for 90 degrees, again, what was the x value for 90 degrees? 0. What was the y value for 90 degrees? And what was the r value? 1. Okay, so if we do all 6 trig functions, we would do sine of theta. Sine of theta is y divided by r. So sine of theta? 1. 1 over 1, which is 1. Cosine of theta, 0 over 1, which is 0. And then tangent of theta, we already did this one, would be, it would be undefined because it's 1 divided by 0, which is an undefined value. But remember, if we know 3, we actually know 6. Cosecant of theta is also going to be what? Because 1 over 1 flipped over, so 1 over 1. What about secant of theta?
0.
Well, it's already, cosine is 0 over 1, so secant is, which means we would answer undefined. Since tangent is undefined, if we flip over that fraction, what is it equal to? 0. Again, this is why I like showing my work, because these 2 values right here were helpful in me knowing what the flipped over version would be, the reciprocal. Okay, an angle theta in standard position with terminal side passing through -3, 0. That's what we're finding. So it's passing through -3, 0. If we just thought about what that looked like, 1, 2, 3, 0 means it's going through this point right here. Oh, let me make that look a little better. Boop.
So does that make R 3?
Very good. So if we were doing this, what is the x value? What is the y value? And what is the r value? 3. Because our radius, if this was making a circle, would be radius 3. Now we can do all 6 trig functions. Sine of theta would be 0 over 3, which is what? 0. Cosine of theta would be -3 over 3, which is -1. The tangent of this theta would be 0 over -3, which reduces to 0. let's do this, the other three that go along with it. Again, seeing my work in getting these final answers is helpful because now I just use the reciprocal. Sine and cosecant go together. Cosecant would be the reciprocal, which means it's 3 over 0. Uh-oh, undefined. Secant of theta, flip that number over, would be 3 over negative 3, which means this is negative 1. And then cotangent of theta would be negative 3 over 0, which is undefined. Nice. Once you know 3, you actually know 6. Now this idea of the quadrantial angles, we've really only technically looked at them through one revolution of a circle. So we had 0, 90, 180, 270, 360. But this last page kind of talks about the coterminal angles of quadrantial angles, meaning as we go along and do revolutions around the circle, they'll end up being the same. So conditions for undefined function values, you just make sure you look at the terminal side. If the terminal side of the quadrantial angle is along the y-axis, remember your y-axis would then be 90 degrees and 270 degrees, or any coterminal angle with those. Then the tangent and secant functions are undefined. If the terminal side of the quadrantial angle lies along the x-axis, which is 0 degrees, 180 degrees, 360 degrees, and every coterminal angle with those, then the cotangent and cosecant functions are undefined. This is just things we can remember to make our work faster. This table summarizes the quadrantial angles in your ones, zeros, and undefines. I don't particularly find this helpful to memorize, more so when we get into the unit circle and the values in different tables I'm going to have you look at. Those are more helpful for remembering which ones are undefined, 0 and 1. Now this caution is written really big here. You guys already kind of asked me about this. One of the most common errors involving calculators in trig is when the calculator is set for the wrong type of angle measurement. Make sure you use that degree mode for right now. We will work in radians in this class. The class before you is AP Pre-Cal, and they're only working in radians for this class entire semester. So you will always need to check your calculator. It will be in the wrong mode. Additionally, when you reset your calculators every time, pressing second plus 712, they go back to radian mode. So you will always need to be checking for degree mode if you're working in degrees. Just something to put in the back of your mind. How do we feel?